Hi, everyone. Thank you for joining us today. This is Caroline Griffin. I am Riot's Event and Operations Manager. I am very pleased to have Ben and Ash here today with us from Ten10. 1010 has been a great sponsor of ours. They've been a partner for over a year now. We're super excited to have them do their first virtual lunch and learn, which is awesome because Ash is not located in the United States. So we're super excited to have this opportunity to have him virtually and his partner, Ben. Just a couple ground rules before we get started. This session is being recorded and will be posted to Riot's YouTube channel for those who are unable to stay for the whole event. If you do have any questions, please either place them in the Q&A box or the chat box, and we will make sure all of your questions get answered at the end. And the participant list is hidden, so do not worry, you're not the only person here. You just won't be able to see the full participant list to protect everyone's privacy. But without further ado, I will pass it over to Ash and Ben. Thanks so much for being with us today.
Lovely. Well, thank you very much, Caroline. It's an absolute pleasure to be here today to present this webinar. Let me just start off here with a couple of introductions. So I'm Ash Gawthorpe. I was one of the co-founders of Ten10. Ten10 is an independent quality engineering and software testing company. We were founded in the UK. We've been running now for, about sort of 13 years or so. And as you mentioned, last year we opened our office in Raleigh, North Carolina, with Ben, who heads up our US office. So I'll just let Ben introduce himself as well.
Yeah, hi everyone. I'm Ben, and so I'm a lead consultant at Ten10. I've been working in the testing space for around 10 years, mainly in the automation and performance arena. As you can probably tell, I am originally from the UK. And yes, I moved over to Raleigh last year, and I've been heading up the US office for us for the past year.
Thanks, Ben. So as a business, Ten10, we're about sort of 300 people strong, and we spend quite a lot of our time advising our clients around how to implement testing practices, and frequently that's around test automation and performance testing across their products. But also we work with a number of clients who integrate a whole subset of products from other vendors, from other clients, and bring them all together to then build on that to provide their own offering. All of these need to be tested, essentially. And more nowadays, what we do, we find ourselves focusing on test automation before integrating all these tests into a continuous build process. And more often nowadays, that's leading to a continuous delivery or continuous deployment process, encompassing many of the techniques within DevOps. So originally, when we first started discussing this with Caroline and with Abby a couple of weeks ago now around what we should do this on, we were just running through our backgrounds. And so my background is a hardware engineer. My degree was in electronic engineering. And my first job was working for a 3D graphics company, essentially as a hardware design engineer. And I was just explaining this. And one thing that Abby was saying, how her background in hardware testing, and how I transitioned from hardware to software, and was talking about some of the larger sort of software engineering processes around quality, around continuous delivery. And she was explaining how what she saw quite a lot was that whilst everyone was very clear on the hardware side of things, when it came to integrating these products and it came to testing, they'd sometimes find problems with regression, for example, where you introduce one fix to a product, but then that breaks a whole load of other things further down the line. And I was just explaining to her sort of how that works and how we deal with that at Ten10. And then she said, well, that might be a good avenue just to explore as part of this webinar, to maybe run through some of our experiences working with many different companies and vendors, some of the challenges we've helped them with. And this is across a broad range of clients. I mean, yes, delivering mobile products, desktop applications as well, but also within that sort of embedded and IoT space there. And particularly the challenges and experiences when these two worlds come together, when you get that sort of boundary between hardware and software and you are passing things over from one team to another. And that sometimes is where we find that that collaboration really helps sort of both sides of that coin sort of understand it, and also enables ultimately these products to be deployed, or the services to be deployed, encompassing hardware, software, seamlessly and continuously as well. So just in terms of what we're going to cover today, so I mentioned there how we can apply automation CI/CD practices within IoT. Test automation for IoT, I'm going to run through this part. There's a couple of slides, and then there's also, it's not a live demo, it's a couple of pre-recorded videos that we've got just showing automation on a number of different platforms and how they all hang together. Off the back of that, Ben's then going to run through performance testing for IoT, and he actually has a live demo which he's going to run through of doing some scalability tests of a number of simulated IoT devices and showing how you can ramp up that scalability testing, the reporting that you can see and that comes from it within a cloud platform as a service infrastructure. And then we'll pull it all together at the end with just summary, key points, and open it up to questions, really. So just to begin then, now I appreciate it's a little bit tricky sometimes when you're pulling together these webinars to understand everybody's experience level and trying to pitch it at the right level. So just hopefully this shouldn't come as new things to many people, but when we talk about continuous integration and continuous delivery, what we're talking about here is the idea of somebody being able to commit code, and then that code being obviously built, a set of automated tests being run against that system, that being then deployed to a sort of staging environment, pulling everything together, and then finally deploying into production. Now, one of the key points here is actually that test phase, and we work with a lot of clients where they see sort of test automation and this move towards continuous deployment as two separate things. But one of the challenges is that if you don't have that full suite of automated regression tests, then you can't stop the world and try to do some manual testing on this thing, because it just slows the whole process down. And where we have seen clients try to defer test automation or try to run a manual test cycle on perhaps just one sprint, that often doesn't work, and they find themselves never quite catching up with that technical debt as a result of it. But this sort of just shows how the whole thing fits together, essentially. In terms of where we've come from a kind of test automation and building this stuff out kind of space over the years, in the beginning, we started off in an environment where we were really just automating applications running on PCs and Unix workstations, really, where whilst all of the communication system to system was the same as it is nowadays via APIs from machine to machine, through database connectivity, through web APIs, either running over HTTP or over direct TCP connections, but the main user interaction side was through a keyboard or through a mouse, and then obviously asserting what appears on the screen. And then all that changed at the first point when sort of mobile smartphones and tablets came along. Initially, we were finding that people were just deploying software on mobiles, on tablets, but it was really quite similar to the desktop apps. Essentially, you were interacting with a screen through a touch screen in this case. The application itself was displaying things on that screen, and you were asserting that what was going on that screen is correct and as it should be. But there were a number of other dimensions that started to appear as well. So a number of those things that have been taken for granted within the desktop space kind of just disappeared, essentially. So the idea of networking, you're going from wired Ethernet or a reliable wireless connection to something that's entirely opposite. Network connectivity is ad hoc. It can be sporadic, and your devices, your systems, your applications need to be resilient to that, and they need to recover when the network does disappear and then when it comes back again. From a power point of view, you have all kinds of issues around power not being an infinite resource anymore. The devices that you have, they use power as your app is running. And we've come across over the years a number of examples where the vendor's application has really been eating its way through the battery, and that really does degrade from the user experience. And also users are quite likely to walk away from the product at that point if they know that it is running through their battery at quite a rate of knots. Also performance. We're in a situation now where the capability of these devices varies enormously between, say, £1,000 smartphone or tablet and $1,000 smartphone or tablet and $100 smartphone or tablet as well. But frankly, the users are expecting a similar kind of experience irrespective of how much that they're paying for their devices or how powerful their devices are. And the other thing to consider is that a new device now isn't the same as that device 3 years down the line in terms of its relative capability to everything else out there in the market. Now, where things started to get really complicated is when people started using the smartphones for real-world connectivity. So the microphone, for example, the speaker, the accelerometer, location services through GPS. This really made the whole idea of testing those things a whole lot more complicated. How, for example, do you test maps, or do you test that a device is in a specific location? How do you test speech recognition, for example, or audio? And how do you test what happens when the device is moved through various, or through space, but also through its rotation as well? Now, all these things can be solved with test automation, and there are tools out there that allow you to simulate and emulate all of these things. You can also actually abstract some of this stuff into the cloud, so you can move away from actually having physical devices to having cloud-based infrastructure, which provides mobile devices that you're able to hire by the hour, for example. So one thing that I was thinking around this is that whilst obviously for most of you guys, you're concerned with the hardware and devices, but I'd imagine that ultimately most of the systems that you end up building at some point end up interacting with, or maybe even those mobile apps, native apps or web apps actually form part of the overall system as well. And so this also needs to be considered as part of your testing strategy. When we then move into IoT beyond this, then one of the key challenges as well is just the wide variety of different platforms that you're able to build these products on. I mean, one of the key assumptions here is that whilst the devices, thousands of them, are all very different, they're really nowadays just running on either iOS or they're running on Android. And I think one of the key consideration is that new devices are coming out all the time in terms of mobile, and users are expected to keep up to date with those. In fact, the vendors provide, make it very easy for you to, and in fact mandate the fact that you need to buy new devices every so often to keep going. One thing we see with clients of embedded devices and IoT devices is that over time, they find themselves having to support far, far more devices and pretty much everything they've ever put out there in the field, versus what happens with those mobile apps, where you always find yourself running on pretty much, if not the latest hardware, then certainly something that's 2-3 years old. Whereas in fact, we're working with clients who, in the case of one client, they've had devices that have been out there in the field for 10 years or more, and they are still expected to support every single one of those devices from a release point of view in terms of the software, and that presents them with a huge testing challenge around how do you make sure that you're testing all those different devices. I'm not going to dwell on this slide too long, but what this really tries to get across is the idea of you can't test everything. And in the mobile space, really what you're wanting to do is to test some of those boundary conditions. So you're wanting to test a device with a low CPU, GPU performance. You're wanting to test at the low bandwidth end of the network performance and at the high end, and the same with screen res. So you establish those kind of boundary conditions to work out if it works on that lowest spec device and it works on the highest spec device, and you can almost expect it to work on the devices in the middle. And so it's really a case of running the full, whilst you'd never really want to run a full regression test, running it on a combination of devices, which are the ones that your users are using the most. Because if you think about that whole continuous integration model, one of the key challenges is that even if you have all these automated tests, they need to run really quickly in order for you to be able to validate that change that somebody's made to the code is correct, is valid, and will not break anything. And so even though this thing is automated, and even though the tests run tens or hundreds of times faster, you still have to be very careful accept the fact that you simply can't test everything. So if you think about some of the sort of additional complexities that you have within IoT, you're really working with those real world physical inputs. So whether that's temperature, weight, audio, movement, video, whatever that looks like, these are physical things in the real world. And if you're trying to automate something and you're trying to deploy it to a lab in lab conditions so you can actually test it, or even virtually, that becomes very difficult. And really what you're wanting to do is to essentially translate these problems, these physical variables that you need to be able to inject into the devices and that the devices look for, and to be able to turn those essentially into software APIs. So you have software control of these things, so you're able to run them through the tests. The same goes for output as well. Many different development platforms, but what we also see is this lack of common test tools. One of the key differences in the mobile space, for example, is that whilst there are a number of tools, they tend to converge on a smaller number of tools by the different platform and technology type. Lack of cloud-based supporting infrastructure, certainly where we've worked with clients, with the exception of some embedded devices, pretty much everything where they need physical devices to be tested actually does require those physical devices to be there, plugged into some kind of lab scenario to allow you to test and to regression test against it. And just that point that web and mobile apps may well still need to be incorporated into the end-to-end testing. And this is where it can get a little bit tricky from the point of view of the hardware world and the software world combining. So just in terms of the overall test architecture around sort of continuous integration, this is something that's taken from the software space specifically, but there's a couple of key themes here really. So when we talk about continuous integration, tools such as Jenkins, for example, as a CI tool, that allows you to plug in pretty much anything that you want to do from a test point of view. So we work with clients where they are testing under the same test, essentially. There will be web applications, there are mobile apps, there are things that are controlled via remote control, there are things that output video output to HDMI, and physical devices as well. The key thing is being able to simulate those devices where you can, so you can actually turn them into essentially a software simulated service of the thing that you're actually trying to test. And in the case of those hardware devices, actually working out what you can do from a hardware point of view to actually do things such as physically press buttons, for example, or to be able to influence controls and sensors under software control. So you are able to raise the temperature, you are able to, under software control, play audio into a microphone, and equally you're able to, for example, capture the output from a loudspeaker. As soon as you have that in place, then you're able to really start thinking about being able to build everything into an end-to-end controllable and automatable framework. So what can be automated? So we generally find that most things can be automated. The key question is that really, do you really want to? And is there a return on investment case for the effort that's often required to be able to make those services automatable? But in terms of some of the things that we've worked with, obviously from a hardware point of view, we've worked with a number of clients. Well, one client springs to mind where they had, it was a physical hardware device which is deployed into a number of medical institutions. And they had sort of more than 100 different versions of this thing live, all with different hardware throughout the world. Now, because these required large infrastructure deployments in order to deploy them, they needed to be put into hospitals, they weren't very keen to upgrade them. So what this meant is that they had this huge amount of legacy systems to support. So when they were changing their software or they were adding new sensors or new devices, they had to be sure that this worked with over 100 different types of device that they had out there in the field. And when we first came to them, they were actually testing these things manually. So they were physically having somebody pressing buttons on devices. They were having somebody speaking into microphones, listening to audio to confirm that that was as it should be. Obviously that's a huge draw on somebody's time and very, very inefficient. So by just being able to take some of common sort of hardware approaches of being able to have those buttons under control of Arduinos or Raspberry Pis or however you want to do that, with a web interface sat in front of that, so you're actually able to control those devices, able to play audio into them and listen to audio back in this case. Oh, and there we go. That's a Raspberry Pi there. So we also work with a number of clients where they have consumer devices. So for example, this is a Roku set-top box, which is controllable via an infrared device. They have lots of different TVs that they need to connect this thing to, for example, lots of different versions of software running on it. And so again, this is an example of how you can automate those systems, of how you're able to drive an infrared remote control under software control, and also how you're able to actually view the output of HDMI and assert that the things that are appearing on the screen is as they should be. This can get a little bit complicated because you've got things like high definition content protection systems preventing you from doing exactly what it is we're trying to do, but there are ways around it to sort of avoid that. And then finally, as a bit of a last resort, and we have resorted to this on more than a number of occasions, actually having things under software control moving around and pressing buttons on touchscreens, for example. Now, this is particularly useful in applications where you're unable to actually get into the device. It just needs to be treated as a black box. Perhaps it's secure. We've used this, for example, in things like point of sale applications in the past. But just coming back to the kind of software automation side of it, in terms of what we have and what tools are out there, one of the key points is that if you do have a requirement to do this kind of thing, you can pretty much build everything that you need to do nowadays with free open source tools. So if you have a requirement to automate web applications, then these are, well, I'd say by far actually the area where there are the richest number of tools out there in the market to be able to do it. But tools such as WebDriver, Testcafe, Cypress, Pufferteer, all of these are free. All of these can be run under control of Jenkins within CI, and you can pretty much write tests in the case of WebDriver anyway, in pretty much any language you want to. There's bindings for pretty much every language you can imagine. If you have a requirement to have to automate or interact with sort of fat client applications, or even some ancient old Silverlight sort of legacy apps, which we, believe it or not, we still have a few clients running those, then your tool choice is limited, but there are still tools out there. One of the challenges, though, is that you end up often having to pay for tools in order to be able to interact with them. RunnerX is a good choice if you're ever stuck and you need something to do that. In the mobile space, again, there's quite a few open source tools out there, Appium, Calabash, that we use fairly regularly. Again, a good choice of languages that you're able to write tests in against these. One thing I would say here is that these applications change. The number of applications and their acceptance and the take-up of them changes significantly. And new tools appear all the time. So it's definitely worth, if you decide on this, run a proof of concept first to make sure that it works with your applications that you need to test and you need to automate. But at the same time, make sure that it's also got some support in the community as well. The last thing in the world you want to do is invest a huge amount of time in building a test framework using some of these tools and then find that they disappear off the scene afterwards. But the ones we're mentioning here, these have been around in the market for a while, and they've actually got quite a footprint out there. So in terms of automation demo, so hopefully this should work. So this is going to be running on iOS and Android devices, again, all using open source tools, automating the same native application on both platforms. So whilst it's the same app, it was actually created by two entirely different companies, two entirely different development teams. Test scripts are 99% the same across both apps. Obviously, that helps if you're able to reuse one set of test scripts across two different apps and two different platforms. And that's a common process that we apply right the way across everything that we do, really. If you can reuse those tests and change the underlying implementation, then that makes a lot more sense. I'm then going to show the same tests running on Browser Stack. And finally, then just another little video showing an automation of a set-top box with the HDMI controlled, of the HDMI output controlled through an infrared remote control. So I just need to play these videos now. So hopefully this will work. But let me just run the first one for you. Fingers crossed. There we go. Yep. So this was running within Jenkins, but what we have here are two actual physical devices, an Android device and an iOS device. Now, for the purpose of this demo, these are actually running through a product called Reflector, which actually allows you to view the output from the screen on a desktop. So what we actually have here are two physical devices that we're running the same tests on. So these tests were written in Java using Appium, all running in a framework called Frameworkium, all running under Jenkins control. So you can kind of see that the app is doing roughly the same thing. Obviously, there are some difference in the controls across the two different operating system types, but essentially what you're able to do there is there we go, the test have run. So that's some reporting off the back of it. Obviously the reporting is quite simple, given that we only ran a couple of tests there, but you are able to build this in, and obviously in a full regression suite you have thousands of tests running, and then you're able to drill down and see what passed and what failed and why things failed, and look for trends and things off the back of that. Oh, here we go. That's the actual of an iPhone 7 there, and yeah, there we go. You can see that's with the camera on. That is an actual physical device being waved around the office. So, but those are running on physical devices. One of the great advantages of a number of tools or a number of products, things like I think I'm going to show you Browser Stack in a second. So rather than you having to go out there and buy all these different devices, if you want to actually run them or run tests on them, which obviously is very, very expensive, Browser Stack, and there's a number of other vendors that do the same thing. They actually allow you to upload those same automation tests and to run these against virtualized devices. So these are not physical devices. These are actually running, well, they are physical devices, but they're running in the cloud, which essentially you rent for a period of time, or you rent on the number of tests that you're running with them. But this essentially allows you to run that full regression suite across a wide variety of different apps and different devices without you having to actually have them sat there. And just one last one here. So this is just showing an example of automated tests, this time using a tool, a licensed tool from called Eggplant. But what you can see here in the top right hand corner, that's the actual test rig, and in the bottom right hand corner you can see actually what it's capturing from that HDMI output. And if you can just see on the left hand side of that laptop, there's an infrared USB stick in there, and that is actually we're actually driving that, driving codes into that in order to actually drive the Roku device itself. Okay, let me just pull the slides back up again. 1 second. So in terms of, just very quickly, in terms of the key learnings, so really the key point there is everything into a testable API. You know, you're able to take those physical inputs, physical controls, and actually have them under software control. Please do consider the longevity of these systems. I know that many of you are sort of in that startup mode, and you know, this seems a long way down the line, but some of our clients, they were there, and they're a long way beyond that now, but they're still having to support many devices that they put out there in the field years and years ago. So just consider maybe a strategy for that. At this point of using a single framework for executing test reporting and monitoring, but using many different automation tools, many different drivers to actually drive the different technology and the different hardware that you have. Collaboration between teams is essential. What we often find is that when companies come to integrate a number of these things together, they'll be presented with a device which is kind of just seen from their point of view as a black box. And whilst another team or the hardware team would have actually, that would have been tested, they would have had far more control over that and far more understanding of how to drive it. That often disappears out the window, and then the new team picks that up as just a black box. And essentially they're having to reinvent the wheel. So collaboration in terms of what exists at the moment and how things can be made more testable, particularly from you hardware guys who have a much better understanding of how to tweak and how to make these devices testable. And then finally, consider the functional and also the non-functional aspects. So really most of what I've talked about here is about functional testing, ensuring it does what it needs to do. Ben is now going to run through a performance test with you. So over to you, Ben. Caroline, if you wouldn't mind making Ben the presenter, that would be great. Let me just see if I can do this.
Absolutely, you should have the. While Ben's getting his slides up, I encourage anyone, if they have any questions, please do put those in the Q&A box and or the chat box. We'll make sure those get answered at the end.
Hopefully you can see that, Ash.
Yep.
Cool. Okay. Yeah. So just to follow on from where what Ash was saying, so that functional side of everything and getting that covered is really great. But then there's also the sort of performance side of it, which takes you into the realms of, how does the application or how does the overall system perform at scale? So there's a lot of overlap with automation, but there's also a lot of differences and different test scenarios that we can look at. So one of the first things is obviously, why is performance testing important? Why do we need to incorporate that into our testing? So first of all, as I said, it shows you how the software or the overall system operates in real world conditions. Everything Ash just ran through there is great for sort of isolated scenarios or single user cases, and it can give you great feedback in terms of how the application reacts when a single user is using it. But performance testing allows you to run through that real world situation where multiple users are using your application and potentially find issues that you might not identify in, say, manual testing or test automation. Similarly, so how it provides insights into the application, how it scales, and whether it can perform under that pressure. As I mentioned, you may have your system that performs perfectly well when a few users are using it, or you're in startup mode, and it may be that suddenly you have a huge spike in users or devices. And you need to know that your application can scale with that, especially under pressure if that spike comes quickly. And again, the operational performance and cost optimization. Again, on the flip side, you don't want to have a system or an overall stack that's overly sized when you don't need to use that. So performance testing can give you an insight into, whether you can scale down. If you know you're going to scale up, how does it scale quickly? And so you can optimize your costs. And if you've got, say, a surge at one period in the year or time of day or something like that, it allows you to optimize your infrastructure to be more cost effective. And then again, so simple changes at code level can impact the overall performance when scaled. So simple changes that you might make at code level, it may be a simple one-line update, it may be an enhancement that can, and again, that might sail through regression testing and work completely fine, but it may actually, once you put it into the real world, that may cause an issue once it's increased and multiplied by multiple users using that same functionality. So performance testing allows you to understand how that would function in a real world scenario. Okay, so some of the challenges that we face with IoT performance testing. So first of all, the complexity of the system. So if you think about a normal software project, you've got your web app tier, maybe APIs, microservices, and then maybe a DB tier, that sort of thing. So you've got a relatively straightforward system. IoT brings in additional complexities that aren't seen within regular software challenges. So navigating around those can be quite daunting and challenging for people to take on. Again, it's with it being relatively new, and again, not many people carrying out performance testing on IoT. The lack of available mature testing tools and frameworks is pretty limited. As Ash mentioned with the automation, there are tools and frameworks out there, but they're not necessarily all mature. So they don't have that support and that longevity that you can rely on and get working when you need to. Remember the realistic workload model creation. So, you may not understand what that's even going to look like or how you would even begin to simulate that. Like I say, you may have devices and then you've got to bring into the users, that side of things. So trying to actually map what that real world scenario would even look like is a challenge in itself, especially if you're brand new to it and you've not got any sort of data or statistics to go on what your system usage might look like. So it's difficult to just come up with that from scratch and understand what that model should look like. And then again, complexities involved around setting up a dedicated test environment. Very much so, if you've got a production environment to then replicate that for a performance test environment, if that's a large environment, that can become very costly very quickly. So navigating around that and trying to manage that correctly can be another challenge that's often seen with IoT performance testing. So some of the key differences here between traditional performance testing and IoT performance testing. So you've got your simulation. So typically, traditionally, you're simulating users, using websites, using mobile apps, that type of thing. Whereas with IoT, you've got devices that you're simulating, sensors, and then also you're throwing into the users as well if you're doing the full end-to-end system type thing. In terms of scale, with traditional performance testing, you're looking at a few hundred users to a few thousand users to create the peak load. Whereas with IoT, you can be talking a few thousand devices to a few million devices. And then data, what types of data are you sending? You send and receive large amount of data per request in traditional performance testing, and then you send and receive minimal data per request. But the data is shared continuously at a timed interval with IoT. The protocols that are used are different. So, standard traditional performance testing is things like HTTP, whereas IoT introduces new protocols such as MQTT and various other ones. So it's non-standard. There's not many tools out there that do support that. And then again, in terms of the requests and responses, it's synchronous in terms of sending a request and receiving that response, whereas generally in IoT, it's a fire and forget mechanism. So that's different in terms of how you'd manage that. So some of the test scenarios in terms of testing the broker side of things. So this is where the devices connect up to that broker, whether it be in the cloud or on premise. So we've got the number of client connections. So how many concurrent connections can a single broker instance handle? So this is even relevant even when you're using cloud providers like AWS or Google Cloud Platform. They do have limitations on what you're able to, how many you're able to connect simultaneously. So looking at that and testing that gives you an idea of where you might need to update your quotas, things like that. But that gives you an idea of how many concurrent connections your broker is able to handle. And then separate to that, you've got the subscriptions and topics at scale. So how many clients are subscribed to the same topic, and then how many subscriptions each client is using. So different types of tests, just different variations of the same test, but changing how you may interact with this application. And that might change how you end up deploying your overall application, because slight changes like that, you may see that the overall application performs better by increasing the number of subscriptions or creating new clients. So again, these things can feed back into the overall performance of the application. And then the message throughput itself. So We've got the fanning, where clients are publishing messages, and a smaller number of clients are subscribed to those topics. And then you've got the opposite to that, where a small number of clients are publishing messages and a large number of clients are subscribed to those. So again, different types of scenarios, just to see how, if there's any impact on the overall performance of the application, and if that changes at all. And then again, the one-to-one, as it says there. So here are some of the major performance testing tools that currently support IoT out of the box with very little additional configuration needed. So you've got Load Runner and NeoLoad, which are your commercial test tools, which you can pay for licenses, and they allow you to run MQTT and COAP protocols. And then you've got open source tools such as Locust and JMeter, which are both open source tools and allow you to scale up using various using your own infrastructure to be able to do that. But there are various tools out there, and you'll find, scouring the internet, there are different scripts and various things available. But as I said, these ones are the ones that almost out of the box will enable you to get up and running relatively easily and have the support available and the community that have already sort of faced challenges that you might face. So I'm just going to give you a demo using one of the tools. So using JMeter. So for those who aren't familiar with JMeter is one of the most popular performance test tools. As I said, it's open source. It's relatively simple. It's been around for a long time, but it has a big community and it has a lot of plugins that allow you to do new things. So as technologies and new technologies are coming out and changing, plugins are being developed that allow you to do various things. So out of the box, JMeter doesn't give MQTT support, but with plugins, that's easily made available. So the scenario itself is a pretty simple scenario, just to demonstrate using it. It's using Google Cloud Platform's own end-to-end IoT demonstration, where it uses basically the concept of a wireless thermostat and a smart vent that opens and closes depending on the temperature that's being fed back. So it uses Cloud IoT, Cloud Pub Sub, and then the cloud server itself has got a Flask server, a simple Flask application that actually allows users to update, so they can read the temperature, the current temperature that's on the thermostat, and then we can choose to update that. And based on that, the application then will send data back to change the config, telling me vent to open or close depending on the temperature. So there's some calculation in there. Like I say, it's a very simple system, but it demonstrates both ends of the system, where the thermostat is constantly updating based on the temperature. So replicating, a hot afternoon where the temperature is gradually climbing, and then an end user updating that and bringing that down, so that changes and fluctuates depending on what the user updates. So I will just, hopefully you can see JMeter. Ash, just thumbs up if you can.
Yeah, I can see that, Ben. Yeah.
Cool. Okay, so this is JMeter. Again, I'm not going to dwell too much on it. There's plenty of documentation out there for people available, to look at JMeter and what it is if you're not familiar with it. But what I will do is just show you how simple it is to quickly create a test that we can ramp up and ramp down. And this allows us to do that full end-to-end scenario that I was talking about. There may be the scenarios where you just want to test the broker side of things, so using the devices and updating the subscription side of things, whereas this scenario also has the users on the back end, where people are posting to the web service, they're reading current temperature, they're updating the current temperature. So you've got both sides of the coin. So to replicate that real world scenario, like I say, it's not a real world scenario, it's very basic and limited, but the idea is that once you put that model together that I mentioned earlier, you're able to do that using JMeter in one single place. So what we've got is JMeter has a plugin that allows you to make MQTT connections. So it's very simple. What we've got is, a connection. So it does one connection per user, obviously, and then that just leaves the pipe open. And then what we have is, in parallel, a subscription that just sits and waits for updates on the subscribe pipe. And then we've got a publisher that is, so this is where it replicates the thermostat, updating the current temperature on a timed basis. We've got it set to 10 seconds at the moment, which obviously is unrealistic, but once you've built in that model, you'd be able to understand over a period of time for your entire system how frequently you would be expecting that to come in. And then on the other side of that, we have users that, as I say, are using, these are replicating users who might be using the mobile app or a web application to view the current temperature or update the current temperature. And again, they have a pause period again, but these are where you could change those variables depending on the overall usage of your system. So currently we've got the test set at, we've got 1,000 devices that will connect and publish and subscribe, and then we've got 300 users that, as I say, connect to the web app and constantly update that. So I'll kick that off, and I should be able to show you. You should be able to see. So there, this is just on my app server. You can now see. So we've got this. The test runs for 10 minutes. I'm not going to hold you for 10 minutes. Don't worry. The test runs for 10 minutes, and what it does is it gradually ramps up over that period to 1,300 users. And here you can just see those users, hitting the web app, getting 200 responses, getting 201 responses when they're updating the temperature, and then also it's reading in those current temperatures from a subscription. And then, like I say, based on whether the temperature is too high or too low, it then feeds back that config to change the device temperature, open the fan, sorry. So if I go here so Grafana is a dashboard, again, that if you're not familiar with, allows you to bring in all sorts of metrics, and we use it for JMeter to give you a real-time sense of what's happening in terms of response times, throughput, that type of thing. So hopefully if I update this now, you can see that in line with the test itself that's running through, the throughput and the active threads that are going in. You'll see that gradually increase over time, but it gives that real-time view of everything that's going on in the test. And again, that can be configured to show whatever metrics you need. There's also then, there's also two ways we can monitor the back-end system. So Google Cloud Platform obviously has their own in-house metrics, but you may not be using Google Cloud Platform as your back-end. So what you can do is you can also pull that into a centralized dashboard within Grafana. So here you can see that we're pulling through monitoring from Google Cloud, and so you've got it all in one place. So you've got your connected devices, you've got your CPU usage, you've got your bytes, and your message count. And so, yeah, that'll update in real time, and like I say, point out any errors that are occurring, and you can tweak and change that depending on what you're wanting to do. So I'll just show you a test that completed earlier in terms of how that finalized graph looks, rather than waiting for the test to complete. But here you can see it gradually ramps up over time and then holds at that sustained period. And you can, from there, understand response times and things like that. And again, depending on what errors you might observe, rises in CPU, this allows you to scale your system and change your system to be capable of handling the volumes that you need to handle. Like I say, this is just a very simple scenario, but the idea is the same, and you can just configure this JMeter test to do whatever complex scenario you might need to do.
I guess the key thing here, Ben, is making sure that those load models are representative. So you have a number of load models to represent different scenarios, different volumes. You can use it to forecast how many users or devices you think you might have out there in the future. You can also use it to model particular scenarios, key events where you may have more throughput, for example. And then, as you mentioned, that allows you to essentially do some capacity planning around the back end of that server-side infrastructure.
Exactly. Yeah. And that's it. It's all about getting those scenarios, and once you've, the tools themselves have a relatively simple part. Once you're able to build up familiarize yourself with JMeter, it's just a case of coming up with those correct models and scenarios to make sure you are correctly replicating what you expect or what you're seeing in a production environment. And it allows you to test that prior to having those problems in live.
Great. Okay, so I think that was pretty much kind of all we wanted to run through today, really. In terms of the things we wanted to show you, what time are we on now? 10:02. So we got a few minutes for any questions, or if anybody wants to run through anything in a bit more detail. Obviously, one thing to point out is that I'm in the UK, but Ben is sort of around the corner, certainly from the Raleigh office. And one thing that Ben does extremely well, actually, is being able to cobble together various sort of performance testing and test automation scenarios as well across a wide range of different hardware and different devices and platforms. So he's there to sort of reach out to as well if you need any help or any advice around anything to do with that.
Wonderful. Thank you so much, guys. We do have a couple questions here. Just very quickly, we had a couple people ask about the presentation. This is being recorded, so it will be on Riot's YouTube channel and then posted to the meetup, so you'll be able to see the slides there. A real easy question. Someone is interested in finding you guys and contacting you guys. Is the best way that email address that we see, contact@ten10.com?
Yes, please. Yeah. Failing that, obviously Ben and I are happy to share our contact details with you. I think you have them actually, Caroline. Very happy for you to share that with people as well if they'd like to follow up with us directly. But if it goes to contact@ten10.com, then it definitely won't get dropped, and somebody will pick it up, and it will be in a process.
Absolutely. I'm happy to share those email addresses when I share the presentation. Thank you so much. So we have a question here from Bill. Bill is a cybersecurity ARC and is wondering if you could give some examples of the testing tools and frameworks.
Yeah, sure. So above and beyond the sort of frameworks and tooling that we've discussed.
He did not go into specifics, Bill. If you could give some specifics, and then we'll move on to a next question and come back.
Yeah, sure. I mean, if as I say, feel free to.
If Bill wants to have a separate conversation, I'd be happy to run through some of the various tools and scripting things that we've come across so far that we can share with him, obviously.
I think it'd be interesting to understand some of his requirements as well, because obviously the tools, whilst the frameworks are often more generalized, as I mentioned, the tools themselves can often be quite specific to what you're actually needing to test and the different platforms and technologies.
Perfect. And Bill just said he will reach out directly. So thank you, Bill.
Thanks, Bill.
Question here from Earl. How is documentation, for example, business rules, etc., mapped to testing parameters?
Oh gosh, so kind of business requirements and how you and how that maps to kind of acceptance criteria within tests. Yeah, I mean that's very happy to talk through that, but that's probably going to be that's not a 1 minute thing to answer really. But there are processes for that, well-known processes for that, which very happy to run through.
Perfect, thank you. Next question here. In my product launch schedule of an IoT product, when do you recommend scheduling the performance testing?
As early as you can, really. We work with, I mean, anytime we work with sort of 50, 60 clients, and the clients we work with across performance testing, You can never do it too early, would be my advice. But key before you start is really to understand those load profiles and understand what you think your usage is going to look like. That's more important than anything. But obviously you need your system that you're designing to be sufficiently far along down the line that you know exactly things like the messaging you're going to be sending, how often, how big those payloads are, what that looks like. But I would definitely say that if you're doing sort of a soft launch and you have a very low number of devices out there, then that's probably okay. But then shortly after that, you really want to start thinking about how to performance test and really understand. You can performance test to understand the restrictions around the server-side infrastructure that you have in place, for example, to know how many devices that can support. And obviously, if you're running this in the cloud and you have some sort of elastic kind of mechanism with which it can ramp up and ramp down hardware capacity, then that's less of an issue. But we find ourselves working a lot with performance testing with clients who, you find yourself almost stepping over bodies on the way to the CTO's office because something has gone horribly wrong, which has meant that they've had a significant failure, and then they're asking the question around performance testing. Definitely good to be on the front foot and using that really as capacity planning. But as soon as you have enough information about your system to be able to model accurately what the actual load will be like from an individual device, for example.
And also, just to add to that as well, the test that I demonstrated there was a full sort of end-to-end test that would assume all components are in place. But obviously you can do component testing at various levels or isolate various parts of the system as soon as they're ready. So just to reiterate what Ash says, be thinking about that performance sort of those requirements and what that should look like as early as possible in that pipeline. And then begin where you can, at what levels you can, as early as possible.
I can never recall working with a client where they said, damn, we did that performance testing too early. I've certainly worked with a lot of people who said we wish we did the performance testing earlier.
Perfect. Thanks, guys. And kind of a follow-up question at that. Will performance testing of an IoT device identify any hazards from a functional safety standpoint?
From a functional safety standpoint, I mean, what you can see when things are on the edge of that kind of performance envelope is that you often get early warning signs of where things are going to go wrong, which can be very useful. In terms of sort of functional hazards, I mean, when you're testing things on the edge, it will give you at the edge of what it can perform too. You'll get an idea of how things do degrade and where things do start to drop off and where the sort of areas are where things might start to fail, to allow you to look at it in a bit more detail if that's what you're meaning. If it's not, then feel free to follow up and we can have a separate chat. Don't know if you've got anything to add to that, Ben.
No, I guess it's just not necessarily the safety side of things, but what you can do is incorporate actual real device testing while you're performance testing or while you're testing the load. So while you can simulate the back-end load using tools such as JMeter, you can actually hook in real devices to actually review and understand real user performance and anything that might happen on an actual device, running a single device as a real world device alongside that, so you can push the full system to its limits while understanding how that end user feels.
Or how that device performs, yeah. So getting the performance test tool to do the heavy lifting of having 1 million simulated devices, but then having half a dozen real ones to see how they're impacted when the system is under that load.
Thank you, guys. Last question here that we'll take today. Are there any techniques to recognize what you don't know / not testing for other than user-reported bugs that you recommend?
That's a good question. There are tools out there that actually start to work on patterns, so that almost kind of self-learn as well. I mean, obviously, one of the challenges with the test is that if you are putting in there those assertions to say this test passes if X, Y, Z is true, or this test fails if A, B, C is false, for example, that assumes that all those outcomes are known. There definitely are tools, and there are things that we do within tests that will look for things that are unusual, so that it wouldn't fail on necessarily directly, because it's not a condition that you're expecting or that you've told the test to be aware of, but that can fail the test if things are outside of normal parameters, for example. It's quite a new area, and it's an area that I think is going to become more and more prevalent in the future. And you're also able to analyze those log files from the apps, from devices, from the test results, and there are mechanisms out there that will allow you to look through those and identify what normal behavior is that it can learn, and then also identify unusual behavior, which would allow you to deep dive into that and then have that be flagged up to a user, which would then allow the user or the operator to then sort of investigate that further to see if there is something that's an issue there. So yes, it's not especially common practice, but there are tools and techniques that will do that and do that. And that, yeah, moving away from those cast iron assertions to more pattern recognition, either in the performance of the system itself or in log files or in other forms of data, to determine what normal is and then to flag up if there are anomalies outside of that. Again, very happy to have a follow-up conversation on that if you'd like to.
Thank you so much, Ash. Well, thank you so much to everyone that attended. Again, this was being recorded, so it will be posted on the Meetup page. I will as well share Ben and Ash's contact information. I really appreciate everyone joining us, especially huge thanks to Ben and Ash from 1010 for being here with us today and sharing their time. Thank you, guys. I hope everyone stays safe. Take care.
Great. Thanks very much. And thank you for hosting this, Caroline. Thank you. Thanks very much, guys, for attending. Thanks. Bye. Bye.